Here we're asked to calculate some probabilities from experimental data recorded here in the table. The first question asks the probability that an individual was issued no tickets, given that the individual is female. As soon as you see the word given, you might realize that this is in fact a conditional probability, the probability of some event given some condition. Now we have to decide what the event is and what the condition is. The event stuff will come right after the what is the probability part. Probability that an individual was issued no tickets. So this event that we're trying to calculate the probability for is that the individual had no tickets, or the column header is 0. So let's use 0. Given that, that's the vertical line, given that the individual is female. We're only looking at female respondents. The formula for the conditional probability is the probability that these two events happened at the same time, 0 and female, divided by the restriction on the sample space, or the condition, the probability that someone is female. And we can simplify that by just looking at the numbers from the table rather than making those denominators cancel. So what's the number of females with 0 tickets? 0 tickets and female, divided by the number of females that we see. So remember, we're looking only at this female column, and from those females, we want the number that got 0 tickets or received no tickets. So the number of 0 ticket and female event that overlap is the 97, and the number of females total are 115. So together that makes 97 divided by 115 is a probability of 0.8435 to 4 decimal places. The next question is also a conditional probability. There's another given that. In fact, the events look similar, right? There's a female and not been issued a ticket or no tickets. However, now they're in different locations. The conditional probability of some event given some condition, has changed for us here. The event now we are interested in, the probability that a randomly selected individual is female. That's the first event, the thing we are trying to assign probability to, given that, or under the condition that they had not been issued a ticket, right? 0 tickets. So now it's a little bit different than the one we had before. Still on top is the both, the probability of 0 and female, or rather I suppose we should write female and 0 to keep it consistent. Probability of female and 0 tickets divided by the probability of 0. Now that's a big change because the condition is what changes the sample space or changes the denominator. First it was females downstairs, now it's 0 tickets downstairs. Again, we can think of these as just raw numbers. So we're thinking of the number of females with 0 tickets. That was 97 still. But the total sample, now we're only looking at those who received 0 tickets, that was 168. So the probability among those with no tickets, the probability that an individual was female, is 97 divided by 168, or 0.5774. The results of this one can help us talk about part C. From the results of this survey, or the probabilities we've constructed, does it appear to be the case that females are more likely to get no speeding tickets? Are they more likely than males? Well, if the probability that if someone has no tickets is a female is 57%, right? So 57% of those without tickets are female. We can use the complement rule to talk about the probability that those who without tickets are male. Since this guy only had 2 possible outcomes, we put people either in the female or male category here. Then the probability of those who are male was 1 minus 0.57, or 1 minus 0.5773809524, or 42.26. 42% of those without tickets were male. So it does appear that in the 0 ticket category of those who don't receive any tickets, females are more likely.